Welcome to today's webinar with the title More Powerful Than Ever, the New Slimflex Technology. The speaker of today's webinar is Mr. Michael Kress, Head of Product and Process Development in our European prototype plant in Roth am See. And now, I wish you lots of fun and new information.
Good morning and a warm welcome to our webinar, the new Slimflex technology. I wish you an interesting and informative time about another technical solution in circuit board technology. At first, I explain you the basics, possibilities for Slimflex, the design rules for the new Slimflex technology, the build-up possibilities for the Slimflex technology, a lot of applications, and Slimflex very robust, a result from our test equipment by this technology. But at first, we start a short survey. What is the smallest PCA pitch you currently use?
So now you can choose one out of these 5 possibilities. And afterwards, we will have a closer look to the results of this small survey. So around about 50% have already voted, and I will wait a few more seconds. 70%, yeah, that's great. Let's see whether we can hit the 80%. More or less, we have that already. So I will wait another 5 seconds, then closing the survey. And this is the result. We can see that already a lot of participants have to use PCA pitch round about 0.3 millimeters, and at least some of you already using PCA pitch even smaller than 0.3 millimeter. Okay, thanks for voting.
Very important. So Slimflex is always used when all other PCBs variants can no longer offer a technical solution. Perhaps for very small components pitches, then a Slimflex is a new technology who can us help from the design. Slimflex is a solution when it comes to flexible or rigid flex PCBs, but not only. Thanks to the thin construction, this technology is ideally suited for small wire pads and fine pitch components. It is also an option when the flexible advantages are not required. You can Slimflex used at a rigid PCB too, but they are very, very thin. These advantages are based on the very thin material substrates, and they get us the benefits from suitable for very small PGA pitches, perhaps 0.3, 0.35 millimeters. We have several we have a lot of several times leak-free, very robust and very reliable, very flexible flex areas possible, and possible with all common solder surfaces. And in our plants, we use a standard solder surface, ENIC, electrical nickel, and immersion gold. For the defined standard, you will find the material build-ups and design rules for our PCB layout. On the left edge, you see here, you can see an 8-layer board. In the middle, you can see a 6-layer board with the variant this option in form of a soldering carrier. This may be necessary to assembly process. On the right side, you can see the option with a glued partial mechanical race formants. The most important details in the design rules, what are different to the old version, is at first the line and the spacing from the layout design. It is possible to use 75 lines and 75 width and spacing by use only micro wires over all layers. The next point, the minimum pad diameter for the micro wire or for your component footprint, it is possible to use a diameter from 225 microns. Perhaps if we need more smaller pads, it is possible to use 200 microns. And why we can make these small pads, very important for this technology is the very thin build-up. It is possible to use, to use the finished hole diameter from laser drilled micro wire only from 70 microns diameter. So this is the solution what we can do for your design as very small component pad. The build-up, what is possible for the build-up? You can use it at first as a 8-layer board perhaps, without bending areas. Or you can use it as a rigid flex board and to use in the bending area perhaps with 4 layers. Or you can use it as rigid flex PCB as 4-layer rigid and 2-layer flex, or 3-layer rigid, 2-layer flex and 3-layer rigid. Or you can use it as complete flex PCB as 4-layer or 6-layer PCB. Slimflex offers a big solution for every application. Come every time to us and we can discuss this. So now the next short, survey number 2. Which BGA pitch will you have to use in the near future?
So there are 3 options. Please choose one of them. So we already got around about 50%, 60%. Yes. 70%. Okay, we will wait another 5 seconds. Please make your choice. Okay, so I will close the survey and we will see the result now. So there are almost 20% with massive higher requirements in the future. So this is impressive. And another round about 20% with the next level of BGA pitch. And the lucky ones, 61%, can stay with the requirements of today. Thank you very much.
Good, perfect, thank you. So now I will show you a lot of application, what we use very small components with a very small footprint. So here you can see a rigid flex board with 2-layer rigid, the middle layer 2-layer flex, and the bottom side with 2-layer rigid. The component fine pitch is a BGA with 350 microns. In the layout design, you can see here, we use stack-up micro wires with a pad size from 200 microns. The special feature, no through-hole wires were used. Why we don't use no through-hole wires? We don't need very thick copper into the hole, so we use only micro wires, and then the copper thickness on the inner layer and on the outer layer are very, very thin. So all inner layer are produced with a maximum copper thickness of 20 microns. The outer layer realized with maximum 25 microns copper. The result, on all layers, we can use 70 micron line and space, and this is possible on all copper layers. And so we have a very good solution for very small components with a very small footprint. Other application, this build-up is an HDI board, rigid technology. They have no bending applications. It's only a multi-layer 4-layer with a HDI board 1 2B1 with a 1 micro layer. The first layer is a micro wire. On the inner layer, we have buried wires with micro wires, and from bottom side, a micro wire too. The thickness is 0.25 millimeter thick. The very thin material build-up include limited tolerances is very important for this application. The material is very, very homogeneous in this build-up. These PCB are used in the particle sensor from the SLIM project, and it is very important, the limited material build-up tolerance for this application. What is the special, however, is that impedance defined. Lines have been designed across all layers, but it's not so easy because the PCB thickness is very, very thin. So the impedance matched from the outer layer and inner layer with 100 ohm differential or 50 ohm single-ended is defined in the layout, and it's very important to use a 1-layer signal layer and both not a next layer, so we need the over next layer for the reference layer. This is very important for this very thin build-up. The big benefits from this construction is a small thickness with very low tolerances, a larger process windows for the soldering process, and the material is very, very strong in the application for this PCB to withstand all external influence in this application and maintain all function every time. This is a high-end PCB for the research area. A next solution, Slimflex is ideal for cable construction. In conjunction with the design option, optimize the electrical connections in impedance too. Numbers and density can be implemented in smallest housings. Thanks of the option in the technology Slimflex, and you can use every time connectors design directly. The build-up can be adapted as required to the requirements of the plug contacts. For example, ZIF contacts. It is possible to make the build-up exactly on 0.2 millimeters or 0.3 millimeters to connect in ZIF contacts. So now we have short array number 3. Which design structures, line and spacing will you need in future for the fan out of your components?
So this time you have again 5 options. Please choose one of them. Okay, you are busy. I can see we have almost 50% participation ratio. Okay, 60%. I want to have 80%, to be honest. Okay, we will wait 5 more seconds. Please make your choice. Okay, so I will close the survey and show the result. We can see there are even some participants who need less than 3 mil line space design, and some of you are still in more or less normal structure. Okay, thank you.
Very interested for me. So we see the Slimflex technology is a new option for you to make the new designs what we will do in future. So I will show you in the next option Slimflex, very robust, short profile from the test, from the qualification. So at first we make a reflow testing. So what is the process about this one? We try before the reflow process the PCBs, and then we go the reflow test profile about IPC, JEDEC, 020 peak, 260 degrees profile. Test process after the cooling phase, the test item is driven again into the reflow after any receptions. The result about this is, you see, no delamination, no pad lifting, no copper cracks. The material composite are very, very stable. This means that the PCB can be soldered very rapidly, and the benefit is, but the material is very, very thin, and so we have very, very less Z-axis coefficient, and so the PCB are very good by stress. The next qualification extract is a thermal shock test. So we use a evaluator. On the top side we have a warm room, and on the other side we have a cold room. In the top we have 125 degrees, and in the down room we have minus 55 degrees. And if the step before we started, we make a reflow test as before with 10 times, cool to the room temperature, repeat reflow, then start the shock test, floor above hot 125 degrees for 50 minutes, then drive floor below in 15 seconds with the elevator to minus 55 degrees for 15 minutes. Then the elevator drive back with the elevator to 125 degrees. This repeated for 500 cycles. And so the PCB have a lot of stress from 500 cycles between the hot area and the cold area. The result about this one, you see no delaminations, no pad liftings, no copper cracks, no change in resistance. The composite material is very, very stable because it is very good and has a very low Z-axis expectation. So the PCB are very, very robust in every time what the application is function. So at last, Slimflex is suitable for very small components with a very, very small footprint. You can use on all layers fine line layouts, for example, 75 microns line and spacing. Option, you use ideally only micro wires between all layers. So without through-hole wires, then you can use the fine line layout on all layers. Excellent thermal stable. The risk of delamination soldering process is very, very less. You can use it for cable constructions, and it is very, very good for the reality life for a very, very long time. So thank you for attention, and now you can come to us with your questions from the Slimflex technology.